Hello guys, today we're going to be doing number 5 from section 1.2, and the question is asking us to find unit vectors u1 and u2 in the directions of the given v and w, and use that to find another set of unit vectors that are perpendicular to the ones we found in the first question. So to begin, let's label a few things to help guide us through this problem. So I'll label the questions, and I'll change the names of the first two vectors that we're supposed to try to find to v hat and w hat, just so it's a little bit easier for us so we can recognize what we're dealing with. So with that done, we can get started. So question 1. Find unit vectors v hat and w hat in the directions of the given v and w. So when a unit vector v is in the same direction as v, its value is just the vector v over the length v, which in this case is going to be 1, 3 over the length of v, which is just v times v square rooted. So this is what you should get. And if you multiply out the scalar, 1 over root 10 and 3 over root 10 should be what you get for v hat. Same thing with w hat. W hat is just w over length w. And this is just going to be 2, 1, and 2. And on the bottom, it's going to be 4 plus a 1 plus 4, which is 9, square rooted, which is just 3. And if you multiply it up, you get 2/3, 1/3, 2/3 for w hat. And that concludes question 1. Question 2, let's try to find unit vectors u1 and u2 that are perpendicular to the vectors we found in question 1. So let's find u1 first. We'll consider u1 to be perpendicular to v hat such that their dot product is 0, because that's what being perpendicular means between two vectors, that their dot product is 0. And the length of u1 is 1, which also means that the length squared is just u times u, and that is 1, since 1 squared equals 1. And knowing that, we can get started with finding u1. So since we're multiplying u1 with v hat to confirm the dot product being 0, we have to let u1 be some vector with two components. So let's call them x and y, and let's try to solve now. So u1 times v hat is just x and y times v hat, the value we found in question 1, which is 1 over root 10 and 3 over root 10. And this is just going to be x over root 10 plus 3y over root 10 equal to 0. Factor out the root 10 from both terms, and we can just simplify with x plus 3y equals 0. Isolate the y, and we get this x to be equal to negative 3y. This is going to be equation 1 out of the systems of equations that we're building. To get equation 2, we'll be looking up here, where we said that the length squared of u1 is u times u, which is equal to xy times xy, which is just going to be x squared plus y squared, and that equals to 1. And this is equation 2. Alright, now that we have two equations, we can plug 1 into 2. So let 1 go into 2, such that x is negative 3y squared plus y squared equals 1. Negative 3y squared, that's going to be 9y squared, plus y squared, which is going to be 10y squared, equal to 1. Alright, divide by 10 on both sides and then square root both sides. You should get y to be 1 over root 10. Alright, plus or minus since we square rooted. So, we'll call this equation 3. Now we can find x by putting 3 back into 1. So, yeah, so it's x equals to 3 times plus 1, which is that, or negative 3, I mean, there's a negative there, so this is negative 3. If we're multiplying by positive 1 over root 10, or if we plug in negative root 10, or 1 over root 10, we should get x being just positive 3 over root 10. And so let's collect it. So with that knowing, we can say that u1 is either negative 3 root 10 when y is 1 over root 10, or 3 root 10 when y is negative 1 over root 10. Alright, that's u1. So let's find u2 now. So u2, so let's consider u2. Let's consider u2 to be perpendicular to w hat, such that their dot product will be 0. Alright, do the same thing. We gotta multiply u2 with w hat. Since w hat has 3 components, we're gonna let u2 be a vector with 3 components. So we'll do x, y, and z respectively. And then we're gonna multiply it up. And you should get 2/3 x plus y over 3 plus 2z over 3 equals 0. Again, factor out the common multiple of 1/3 to simplify to 2x plus y plus 2z equals 0. We'll put a star by this. Alright, then we can isolate the y. So we get that y is 2x minus 2z. Alright. Now in that, we could try to utilize the statement that u times u will give us a 1 length. But that means that we would have to square the value of y, which is negative 2x minus 2z. And that would be too complicated for us. So we'll just look to the vector that we use to substitute, or to name u2. So we'll say that u2 is equal to xyz. In column form, it looks like this. So let's use the value of y that we found and put it there in its row. Just like so. From here, you can look, we can try to separate this vector into a linear combination. So we'll just make the scalars be x and z. and the vector is going to be the y that we're going to use to solve u2. So let's do that. So there we go. So how do we get x on the first row? We have to multiply by 1 over here and 0 over here. We have -2 and -2 for the second row, so that's what we're going to do for coefficients. And we need just z, so 0, 1. That's our combination. Alright, so these two vectors are able to be y. So let's just take the first one for convenience sake. So let y equal to 1, -2, and 0. So length y is just the square root of 1 squared plus -2 squared plus 0 squared. That's just going to be 5 square rooted. So I'll say that u2 is just y over length y, which is just 1 root 2, or -2 and 0 over root 5. And we'll just say that this is the value for u2. Alright. If you use this y value, you're just going to get the same thing you got here, just in a different order. But if you did that, it's still right. So if we're done with that, we are done with the problem. Alright, thanks guys. And I'll catch you guys in the next one.